Good day everyone. Before we start this video, let me introduce myself. I am Shan Ian Musa, fourth-year college student from Colegio de Montalban, taking a Bachelor of Science in Business Administration, major in Human Resource Development Management. In this video, we will talk about quality control in production and operations management. Quality control may define as a system that is used to maintain a desired level of quality in a product or service. It is systematic control of various factors that affect the quality of the product. It depends on materials, tools, machines, type of labor, working conditions, or etc. Quality control aims prevention of defects of the source, relies on effective feedback system, corrective action procedure. Quality control was defined by Joseph Juran, ANSI Standard 1978, and Alford and VT. According to Juran, quality control is the regulatory process through which we measure actual quality performance, compare with standards, and act on the difference. According to ANSI or ASQC Standard 1978, quality control is defined as the operational techniques and activities which sustain a quality of product or service that will satisfy given needs. Also, the use of such techniques and activities. According to Alford and Beatty, define quality control as, in the broad sense, quality control is the mechanism by which products are made to measure up to specification determined from customers' demands and transformed into sales engineering and manufacturing requirements. It is concerned with making things right rather than discovering and rejecting those made wrong. Types of quality control. Quality control is not a function of any single department or a person. It is the primary responsibility of any supervisor to turn out work of acceptable quality. Quality control can be divided into three main sub-areas. Those are offline quality control, statistical process control, acceptance sampling plans. Offline quality control. It is a procedure dealing with measures to select and choose controllable product and process parameters in such a way that the deviation between the product or process output and the standard will be minimized. Much of this task is accomplished through product and process design. Here's the example of offline quality control are the Taguchi method. Statistical process control involves comparing the output of a process or a service with a standard and taking remedial actions in case of a discrepancy between the two. This also involves determining whether a process can produce a product that meets desired specification or requirements. Acceptance sampling plans. A plan that determines the number of items to sample and the acceptance criteria of the lot, based on meeting certain stipulated conditions, such as the risk of rejecting a good lot or accepting a bad lot, is known as an acceptance sampling plan. Steps in quality control. Step 1. Formulate quality policy. Step 2. Set the standards or specification on the basis of customer preference, cost, and profit. Step 3. Select inspection plan and set up procedure for checking. Step 4. Detect deviation from set standards of specifications. Step 5. Take corrective actions or necessary changes to achieve standards. Step 6. Decide on salvage method to decide how defective parts are disposed of, entire scrap or rework. Step 7. Coordinations or quality problems. Step 8. Developing quality consciousness both within and outside the organization. Step 9. Developing procedures for good vendor-vendee relations. And that's all about my report. Thank you for watching and listening my video.
Good day, everyone. I am Paulo H. Mercado from BSBA 4B, and my topic is about objectives and benefits of quality control. Objectives of quality control. These are the 7 objectives of quality control, and number 1 is to improve the company's income by making the production more acceptable to the customer, by providing long life, greater usefulness, maintainability, and etc. Number 2, to reduce company's cost through reduction of losses due to defect. 3. To achieve interchangeability of manufacturers in large-scale production. Number 4. To produce optimal quality at reduced price. 5. To ensure satisfactions of customers with productions or services or high quality level, to build customer goodwill, confidence, and reputation of manufacturer. Number 6. To make inspection from to ensure quality control. And the last is to check the variation during manufacturing. And if a company has a good quality control, these are the benefits that they may enjoy. Improving the quality of products and services, increasing the productivity of manufacturing processes, commercial business, and corporation, reducing manufacturing and corporate costs, and determining and improving the marketability of products and services, and they reducing consumer prices of products and services, improving and or assuring on the deliveries and availability. And the last is assisting in the management of an enterprise. That's all. Thank you.
Good day, I'm Alin Maykaya, and I will represent the tools for the quality control. To make rational decisions using data obtained on the product or process or from the consumer organization, use certain graphical tools. These methods help us learn about characteristics of a process, its operating state of affairs, and the kind of output we may expect from it. Graphical methods are easy to understand and provide comprehensive information that they are viable tool for the analysis of product and process data. These tools are effect on quality improvement. The 7 quality control tools are Pareto charts, check sheets, cause and effect diagram, scatter diagram, histogram, stratification graphs or flowchart, and control charts. And now, let's talk about the Pareto charts. Pareto charts help prioritize by arranging them in decreasing order of importance. In an environment of limited resources, these diagrams help companies to decide on the order in which they should address problems. The purpose of the Pareto chart is to highlight the most important among a typically large set of factors. In quality control, it often represents the most common sources of defects, the highest occurring type of defect, or the most frequent reason for customer complaints, and so on. And next is the check sheets or defect concentration diagram. Check sheets that facilitate systematic record keeping or data collection observations are recorded as they happen, which reveals patterns or trends. Data collection through the use of a checklist is often the first step in analysis of quality problem. A checklist is a form used to record the frequency of occurrence of certain product or service characteristics related to quality. The main benefits of check sheets is they enable faster capturing and compiling of data, allow the data to be recorded in a consistent manner, and enable capturing essential contextual and descriptive information that otherwise may be overlooked or forgotten. Check sheets are often used for collecting failure information at specific steps. Next is the cause and effect diagram. It is sometimes called as fishbone diagram. It is first developed by Karl Ishikawa in 1943 and is sometimes called as Ishikawa diagram. The diameter helps the management trace customer complaints directly to the operators involved. The main quality problem is referred to fish head. The major categories of potential cause structural bones and the likely specific cause to ribs. It explores possible causes of problems with the intention being to discover the root causes. This diagram helps identify possible reason for a process to go out of control as well as possible effects on the process. And next is the scatter diagram or scatter plots. It often indicates the relationship between two variables. They are often used as a follow-ups to a cause and effect analysis to determine whether a stated cause truly does impact the quality characteristics. Next is histogram or bar charts. It displays the large amounts of data that are difficult to interpret in their raw form. A histogram summarizes data measured on a continuous scale showing the frequency distribution of some quality characteristics. In statistical terms, the central tendency and the dispersion of data. Often, the mean of the data is indicated on the histogram. A bar chart is a series of bars representing the frequency of occurrence of data characteristics. The bar height indicates the number of times a particular quality characteristics was observed. Next is the flow charts. It shows the sequence of events in the process. They are used for manufacturing and service operations. Flow charts are often used to diagram operational procedures to simplify the system. They can identify bottlenecks, redundant steps, and non-value added activities. The realistic flowchart can be constructed by using the knowledge of the person who are directly involved in the particular process. The flowchart can be identified where delay can occur. And the last in the 7 tools of quality control is control charts. It distinguishes special causes of variations from common causes of variation. They are used to monitor and control process on an ongoing basis. A typical control chart plots the selected quality characteristics found from subgroup of observations as a function of sample number. Control chart shows the performance of a process from 2 points of view. First, they show a snapshot of the process at the moment the data are collected. Second, they show the process trend as time progresses. Process trends are important because they help in identifying the out-of-control status if it actually exists. Also, they help to detect variations outside the normal operational limits and to identify the cause of variation. And that's all for the presentation of quality control. Thank you and God bless.